Hello again, sixth grade. Um, it's me again. It's still Saturday. I've been working on thinking about renewable energy all day. And now it's actually really late and it feels a little bit like fall outside. And I get really excited during spooky season. Halloween's my favorite, so I've got my Dracula cup full of mineral water. I have my fall scented candle. Although late at night, I know better than to light things because I might fall asleep and that's just not safe. Um, I have a great glass pumpkin in Slytherin colors, so okay, I think this should be a pretty good, pretty fun online lesson, but also it's so far past my bedtime that I'll have to go back and do some fact checking later. All right, so earlier today I made a video kind of giving a general intro to renewable and non-renewable energy and introducing us to our current standard, which is 6.ESS 3.1. Differentiate between renewable and non-renewable resources by asking and answering questions about their availability and sustainability. And we went through and talked about all those words and what they mean. And I realized later that video was almost an hour long, which is, I mean, that's like being in class. So if you are quarantined, I guess I'm trying to make the experience as real as possible for you. If you're not and you're just trying to get a quick review, it's not that helpful. So for the rest of the energy lessons that I'm going to record, I'm going to try to break them up a little bit. This should be the last long one, and I will try to keep it not quite as long as the other one. All right, so I'm going to go ahead and switch this over to presentation mode. Yes, allow. Okay, so from presentation mode, I'll pin myself to the board, which sounds horrifying, but again, it's spooky season, so anyway. So, what I would want to do is go to Google Classroom. At this point, you can see that I put this up earlier this afternoon. Sorry, these glasses are just sliding off my face. And now I can't see anything. All right. So, I have down here just a reminder to join our class Instagram, class TikTok if you want. I put one of the class TikTok videos up. That's a great opening shot. And I just take you through and show you, okay, well, that's not really gonna work, I guess. So I go through and just show you how available a lot of renewable energy sources are just, by taking a walk through, just the basics of my yard. So it's a short 3-minute video. Definitely you can see why redheads don't go in the sun. It's fine. Okay. So we also have that 52-minute long lesson from earlier and our notes. Again, the notes for this unit, we are putting them in a slideshow format because there are so many things that I want us to be able to access. So you'll notice a lot of this kind of brown text. If you're in presentation mode, these will almost all be links. This links just back to, again, that 52-minute long lesson. But going through and looking at these, you'll be able to see a lot of links to a lot of videos. All right, if you're not in presentation mode, all you really need to do is click on that and you'll be able to go straight to the links. So we got through our first standard, we discussed what renewable means, we discussed what non-renewable means, and we hit the basics: wind, sun, solar, hydroelectric, geothermal, biomass, oil, natural gas, coal, nuclear fuels, and they have their own little thing. We talked about availability, we talked about sustainability. And then we did a little check-in. So my agenda for this is to keep it short-ish. I feel like I've already gone on for a while. Introduce our second standard that goes along with this, and continue breaking down this first standard into language we can understand. And, I know that I harp on and on and on about the standards and making us repeat them again and again and again, but I can't stress to you enough that, like, the standards tell you what you're learning. And if you don't know what you're supposed to be learning, how are you going to know if you learned it? You have to be able to look back at that standard and say, like, oh, okay, yeah, I know what questions to ask to determine availability. Those are kind of like your guiding principles that you need to be going on with all the time. Um, oh, it's a tough call between vision and slick nose. Anyway, so that's why I go on about the standards at great length. So going back into our notes and starting out today. So today we start here. We talked about that standard that we had yesterday, and I kind of put it in some real world language. I also have some chalky milk, just let you know. I can tell the difference in types of resources by looking at them and by seeing how easy it is to get and to use them. That's that availability issue, and how long we'll be able to use them. And that's sustainability. Is it short term, long term, in perpetuity, meaning forever, whatever. All right, so now we get into 6.ess3.2. Again, I've italicized our verbs, our doing words, so we know what we're supposed to be doing. And I have underlined any vocabulary that I think might be new to you. So here we have investigate and compare. We've talked about investigations. We are taking a look into things at a deeper level. I compared it to a crime scene earlier, and thinking back, that's probably not the best thing, but it seems like investigate's a word that comes up with crime a lot. But we can investigate a lot of stuff. It just means to kind of, put some extra effort into researching and finding out about something. Compare. We know what comparing means. We're looking at things, finding their similarities and differences. Existing and developing technologies that utilize renewable and alternative energy resources. Okay, so existing means it's already there, right? Developing, if we say, oh gosh, I don't know, if I say like God of War 7 is already in development, you guys are going to know what I mean. It's in the process of being made. It's being made, changes are being made as it's being made, tweaks are being made to improve it. It's being developed into what hopefully will be a good final product. So existing and developing technologies that utilize, fancy word for use, renewable, and alternative energy resources. I don't know why they threw the word alternative energy resources in here. My guess is mostly for biomass, things like using biodiesel as an alternative or a substitute for regular diesel fuel. I don't know. It seems like strange wording, but we have it, and I will real worldify that language a little bit later. Okay, so looking at renewable energy sources, we do have to acknowledge that there are pros and cons to these. So, in the event that we're not 100% sure what we're talking about when we're thinking about pros and cons, a pro of something is a good quality that it has, something good about it that we can celebrate, that we would really want to have be part of it, and a con is something that's not great. So just like with fossil fuels, there are pros and cons. The same goes with renewable energy resources, and we're going to look at some of those right now. So some of the pros, because they are renewable, by definition, we can never run out of them. For the most part, these fuels themselves are very cheap. Sunlight is free. Wind is free. Biomass, a lot of times is free, but if it's not, it can be done very cheaply. Geothermal energy is free. It's widely available. Everywhere. Almost everywhere gets sunlight. Most places have wind. Geothermal energy, it pops up all over the world in all kinds of places, especially along tectonic plate lines where you have kind of heat from the earth escaping through those slabs of crust. We have lower environmental costs. These don't produce the same amount of air pollution. A lot of toxic gases like carbon monoxide, H2SO4, which is sulfuric acid, gets produced by a lot of fossil fuels and enters our atmosphere, and then we breathe it in, and it's just not great. We'll see how some cities that really overuse fossil fuels, the lung health of people there is akin to people who smoke a couple of packs of cigarettes a day, and these are healthy people who don't do that. It's just from air quality. Lower carbon emissions. When people talk about carbon emissions, what they're talking about mostly is carbon dioxide, which is the same thing we exhale. But in large enough capacity, when it starts making up more of the atmosphere, it becomes a real problem. Some carbon dioxide in the atmosphere is great. It helps keep Earth warm. Too much helps keep Earth a little too warm. It's sort of like adding an extra blanket you don't need. Job creation, switching an infrastructure or kind of the inner workings of a society from something that runs on fossil fuels to something that runs to renewable energy or runs on renewable energy has the potential to create a lot of jobs, both in the building of these things, the implementation. You have all the customer service jobs that go along with, any kind of power production, energy production. And again, it's not the same as energy can't be created or destroyed. We're using that colloquial version. And self-reliance, which is a strange concept, but it is a geopolitical concept that is worth noting. When we talk about self-reliance in the energy sector, we are talking about the ability to provide our own energy sources close by, making us less reliant on other countries, less reliant on having to send our money and resources to other countries to purchase oil or gas or whatever the case may be from them. And when you have a self-reliant grid, that makes you a much more stable economy and much more stable from a safety point of view. Now, those are all great things. There are some cons. We have two problems that we'll get into a little bit more because these are big words. One is the intermittency problem. The other is the dilution problem. These things they're not nothing, but they're not the end of the world for renewable energy. It is expensive to build and implement new technology. It's always going to be the case. And we're still developing technology and trying to make renewables better. So we are likely to kind of run into the situation where we take our time, build something that's expensive, then come up with something better and have to kind of keep replacing it for a little while until we get to the point where we're kind of at maximum efficiency for things. It is hard to store energy and hard to transport energy. And that seems like a weird concept in the first place because that's not really how we do things. We create energy, we create power where we need it and use it when we need it. But if, for example, we wanted to use, I don't know, Yuma, Arizona, the sunniest place in the United States, to create a massive solar power plant, something that could power the entire West Coast. That's great. We could probably do it. However, we have to figure out how to get that power to places like Los Angeles, San Francisco, Seattle, all the way up the West Coast. And you're either going to have to do that by storing it in some kind of battery or something akin to a battery, which is difficult, or figure out how to transport that energy, and that's a big problem. And then there are some environmental impacts. Whereas a lot of these don't cause air pollution, there are some other things. So let's take a quick look. This is just a 5-minute-ish video, kind of prompting some of the ideas that we just talked about and thinking about whether or not the world could be run solely on renewable energy. I like this video a lot because it brings up a final solution no, sorry, it brings up a solution at the end that I'm a big fan of. And it kind of mentions what I would call diversifying the energy economy, meaning that we would use renewables where we can and where it makes sense. If we're in Yuma, Arizona, and the surrounding area, absolutely we should be using solar. If we're in an area that has a tidal range of 30 feet, tidal energy might be a great opportunity. We here in East Tennessee, we have all of our great rivers. Fun fact, none of the lakes around here are real. They were all created. Tennessee has only one natural lake, and it's Reelfoot Lake in northwest Tennessee. Um, but we're able to use hydroelectric very effectively because we're a water-rich area with a lot of rivers that are great for building dams. So the idea that we should be using renewable stuff where it makes sense and using different kinds in different places is one I really like. So I'll shut up for a few minutes and let you listen to somebody else talk. I put my money on the sun and solar energy. What source of power? So I just want to point out to you guys, and yes, I do have a gallon of mineral water next to me. 50 years, even 100 years with the rate of medical progress, these things are within your lifetime. So a lot of things in science, I can easily understand why you think this doesn't apply to me. This absolutely applies to you because you're going to run out of this stuff while you're alive. So start planning for it now. I just thought that looks a little like a Rube Goldberg device. So I do want to point out something here. This video also goes along with our current standards really well because it asks us to look at and compare current and developing technologies. I'm actually going to back out here so I can make sure I'm really addressing the crowd. And this does this quite a bit. It goes through and says, here's the current technology. The problem with superconductors is that they have to be cooled. We need to figure out how to find superconductors that will operate at room temperature or outdoor temperature. Um, and then in that second one, the reference, or the one that I paused on, not necessarily the second one, the one that I paused on, it brought up the idea of turning solar energy into chemical energy. So we've already talked about something that does this in nature, and I'll be very excited when I get to talk about it a little bit more. We know this is what plants do, right? When they photosynthesize, they take in solar energy, they take in light, and then in their chloroplast, there's chlorophyll, and chlorophyll is able to take that solar energy and convert it into glucose, which is our most basic food molecule. So plants are already doing just they're just out there doing it. Like, they didn't go to school for it. They didn't go to MIT and get like 18 degrees. They haven't spent years in a lab. They're just out there like in the dirt, growing, doing their thing. And they are doing what humans are trying to master. So we're kind of trying to copy plants, right? We're trying to figure out how can we turn solar energy into chemical energy. Um, and in some ways, I mean, biomass is doing exactly that, right? It's using plant matter to fuel things, but we'll get into that more later. But anyway, I just think that's kind of exciting. I'm a nerd. Okay, so I do value your work, Ted Ed, and I do support you on Patreon. Okay, so again, I like that video because I feel like it aligns with our standards very closely, and it kind of does a good job of hitting on the problems with renewable energy while still offering hope. And I mean, you'll learn in Mr. McQueen's class that hope was the last evil left in Pandora's box, but I still think it's one that we need. All right, so I'm sure I'm running on to like 2 hours now, but I'm going to keep going. So, we talked about this, and I said I want to come back to these two issues of intermittency and dilution. So, what are these? So when we talk about, I have the notes here. You can go back and read it. When we're talking about renewables, we talk about intermittency problems. So what this means is that not all resources are available in all places at all times. Duh. All right, so like not a huge stretch of the old noggin up here to realize that the sun sometimes, like, it's so weird. The sun doesn't always shine. Like, there's this period, I don't know, I feel like it's a little while after I get home from work and like the sun just kind of goes away for a while and it's gone for a few hours and it's like not shining. I think they call it night. I mean, come on, of course the sun's not shining all the time. There may be an issue where you have several very, very, very cloudy days and you can't get enough solar energy to, provide all of the needs that you have. It may be the case that you live in a place like Alaska, you're up above 66 degrees north latitude, and during your summer months, you get no sunlight. No, I'm sorry, during your winter months, you get no sunlight. So solar energy is not the most viable option. Um, that's going to be the case with a lot of things. Guess what, guys? Sometimes it's not windy. Um, these intermittency problems are real, and they are things to be concerned with. But does that mean that we should not use these things? No, maybe it just means we shouldn't be counting on solar power at night, or we should figure out ways to store the power that we get during bright days. Maybe we shouldn't build wind turbines where it's like famously not windy. Maybe solar power like isn't the best choice for Alaska in winter. I mean, it's fine. The other problem is the dilution problem, and this is talking about the comparative weakness of renewable energy sources to what we would get from fossil fuels. So fossil fuels are hydrocarbon rich. They have tons of like little chemical bonds in them, and they're just like that. And then you set them on fire, and they're just like boom, 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 boom. All these little bonds are breaking, and they just release tons of energy. It's very dense. When we're talking about solar or wind or something like that, it's going to take a lot more time to kind of generate that same amount of energy. It is not a concentrated bit of chemical energy. We are using mechanical energy to generate electrical energy. Because we're not releasing any of those chemicals and dangerous chemicals, that's what takes away the pollution aspect, and that's good. It's just that comparatively it is a little weaker, substantially weaker. We have to spend longer um, collecting sunlight than we do to burn a piece of coal. But the nice thing about the sunlight or the wind is it's not going to poison the air and we can't run out of it. So it's a problem, but it's one that, like, I think as technology improves, will diminish. As we improve efficiency of technology, I think it will again diminish. And these problems are something to be considered, but not something to, again, like end our hopes and dreams of a renewable future. All right, I wonder how long I've been talking. Probably a while, but you know what? I'm gonna keep going, guys. I just want to get through this. Okay, so we've kind of hit to this, and the last two things I'm gonna hit on are just like two of the big ones, right? Solar energy and wind energy. So, solar energy comes from Sol, which is the name of the sun in astronomical terms. Solar energy is energy from the sun. Fun fact, it is the source for almost all other renewable energy. Solar energy causes uneven heating of the Earth's surface, and that is what causes winds. Solar energy causes evaporation of water, which then rises and then condenses into clouds. The clouds move and then they condense even further around condensation nuclei, and they rain, and water falls and moves in other places. This is the water cycle. It's driven by the sun. Wind energy, hydroelectric energy, biomass, if we're looking at like using plants, guess what? Plants need the sun. Like all of our other renewables, with the exception of geothermal, are gonna come from solar energy. Like it's the OG. It's the OG renewable. All right, so we do have solar power plants, as you can see kind of in this picture down here, these massive setups of photovoltaic cells. The way these work is pretty interesting. It's sort of like Connect Four with electrons. It just starts popping electrons out of holes and having other electrons pop in and fill the hole. And anyway, it kind of goes on and does that and produces electricity. Producing photovoltaic cells, one of the downsides, they are expensive to produce. They're getting less so. And it was the case that they didn't produce quite as much. They weren't quite as efficient at collecting the amount of energy that was being delivered by the sun, but they're getting better and better and cheaper as time goes on. Again, you're not going to set up you're not going to like move to Barrow, Alaska and be like, let's set up a solar energy plant. We're going to set these up in deserts. We're going to set these up in places where they get a lot of sun all the time. So commonly we use these for like local things. I noticed in my neighborhood, and I'm not dumb enough to actually post my address up here, but I did notice in my neighborhood that one of my close by neighbors has, oh, come on, Zoom, Zoom, baby, Zoom. I never thought I would wish for Zoom again, but here I am wishing for Zoom. Okay, so coming through here, there are the woods. Yeah, here we go. I noticed that this particular neighbor of mine installed a ton of solar panels on the back of their house. And there are several people in my neighborhood who have done this, not to that extent. So I'm trying to find some of the other ones. Just zooming around the neighborhood here. I feel like, oh, here's some. I feel like tons of people in my neighborhood have pools and none of them ever invite me over. So maybe I should be a little friendlier. I don't know. But anyway, this house, beautiful house, they installed just this. This is a really big house, and their entire southwest facing roof is covered in solar panels. So I actually went and talked to them and found out that they are making enough money in the summer off of, or they're producing enough electricity from these photovoltaic cells that they're actually selling electricity back to the local electric company, which I thought was pretty cool. But most of the uses that we're going to see outside of power plants are local. People put them on houses. I have a neighbor who has solar powered lighting all over that. A lot of us have solar powered lighting in our gardens. And one of the things that I think is so cool is what's called solar ivy. So these are solar panels that are more closely modeled. We call it biomimicry, meaning that we are looking to mimic how photosynthesis works or how things that are living work. And we're creating what is called solar ivy. So the way these work, actually, they do start turning solar energy into chemical energy a little bit more. And they also wind up looking a lot like ivy. So everybody loves an old building covered in ivy, right? Plants make everything look better. So, rather than just being kind of these difficult panels to stick on top of things, you can now invest in solar ivy, and I think I actually put a picture in the notes. This is all solar ivy here, and then these are trees. You can invest in solar ivy and kind of power your house that way. We have photovoltaic panels that you can plug into your phone, leave your phone out for a while, and it's there. I noticed the last time I was on ETSU's campus that a lot of the umbrellas over tables have solar panels on them, so you can charge your devices there. We have solar powered backpacks. It's becoming just more and more and more common, and I love it. I love seeing it. Again, we do run into that dilution problem, that intermittency problem, but does this mean we shouldn't use it? No, it means we should use it where it makes sense. Any of these, great idea, makes sense. Here, makes sense. Here, it makes sense. In a frozen wasteland that doesn't get sun, maybe it doesn't make so much sense. These do also link out to videos, just so you know. I won't make you here. Okay, actually, these are only 2 minutes. I will make you watch them. I told you it looked like Connect 4. I told you. Okay, so I like that. It brings up the idea that like one of the things with solar energy is you just need a place to put it. So a lot of cities I've noticed, I spend a lot of time just kind of like, I don't know, Google stalking the earth on Google Maps. And I've noticed that as I look at larger cities, especially cities in sunnier places, over the last 10 years, I've seen more and more and more buildings creating their own grids by putting solar panels on top. And yeah, if you can find a place to put it, it's great. A lot of our road signs and things are solar powered, so good for solar energy. You go, sun. All right, and finally, we're going to land on wind energy because this teacher mama is getting super sleepy. Okay, so wind energy. It comes from moving air, which is defined as wind. But how does it wind up coming to exist? Our book does a very good job of explaining it, and I will be posting kind of how I've highlighted things on in our book. But basically, what happens is different surfaces on Earth heat unevenly, and when we have differences in heating, we have differences in air density, right? So when we talked about convection, we talked about things near the heat source, they get less dense and they rise. Things that are over surfaces that heat very quickly, they will become less dense and rise. We'll have cooler air, it will rush in. And this changing in air pressure is what creates wind. So, again, powered by the sun, but wind on its own is a good source. So, we use these enormous wind turbines, and you can't really tell from these, but I mean, these things are like 500-600 feet tall at least. They are massively big. They have to be like half a kilometer apart. They are extremely expensive to build. The materials that we use to make them are lightweight, durable metals that are pretty rare, and also because they are rare, they are so expensive. However, once they're installed, they're very inexpensive to operate because the only thing you need to operate them is, wind. But it is worth noting that they are expensive to build. So a lot of things like solar panels, they take up a lot of space. When we looked at the solar power plant, we saw lots and lots of land just being used by the photovoltaic cells. The land around turbines is available for use. This is in what's the English word for it? The Netherlands. And tulips are a major export there, and all over the tulip fields and all over farms across the United States, we see wind turbines. There, if you have half a kilometer between there, that's about 500 meter, 1,500 feet. You have a lot of land in between that you can use for farming, for a lot of things. You don't necessarily want to build your house directly under one. That's probably a no-go. But it's great because it does free up a lot of land and allow you to use the existing air. Admittedly, these have been kind of an issue for birds. Um, it's really not as funny as it sounds. Um, so, as these things are spinning, of course, they're large, spinning, sharp blades, and migratory birds have been known to fly into them, and this upsets a lot of people. One great thing about it, there's no air pollution whatsoever. It's literally just wind making the power. It's been used for centuries, actually. If we look here, we see an old windmill. This is an image we should all be pretty familiar with. These used wind energy to, rather than turn a turbine to create electricity, they would turn a large stone, what's called a grist, inside and grind different grains and crops and things like that. So, we've been using wind energy for a while. We still do have the intermittency and dilution problems. Sometimes wind isn't blowing. And it does take a lot of land and a lot of time to get a lot of energy from wind. So, I asked the question, how could we make this tech work better? One of the things that I'm a big fan of, and I've noticed Holland, Denmark, a lot of, the Netherlands, Denmark, a lot of Scandinavian areas, places along the Baltic Sea, they put their windmills, their wind turbines, you can see some here, and I did pull up some pictures. Oh, look how pretty those are. Those tulips. They do a really good job of building along the coast and kind of in the ocean. And if you think about it, this makes a lot of sense. You always have a breeze going at the beach because land and water heat very differently, so there's constantly wind going on there. So when we look at something like this is a brilliant design for how to use that. This isn't an area of ocean that would be used for anything anyway. It wouldn't be prime for shipping. Here we have again this kind of like nice. We have it over here, along this coastal area where there's always going to be a breeze. So that's one way we could make this work better. I would love to hear your thoughts on other ways we could make this work better. It's improving constantly. So that's will about wrap us up. I will play this little 2-minute video for you here, and then we'll wrap this video up. I'm sure I'll see that it's been an hour long as well, and we still have a lot to go. Okay, so we'll kind of use that as our ending point for this longer than intended lesson. Hopefully, you have learned things with me. If you have any questions, please feel free to email me. I hope everyone is well. And, again, please remember that if you are not well, priority number one is your health. Please take care of yourselves, take care of your families, and this stuff isn't going anywhere. The only thing that might happen is we might see a massive development in I don't know, technology before you get to it, but take some time for yourself. Take some time to be well. Um, Thank you for watching. Blessings to everyone out there. And I hope to see you guys all in class soon.